Hi everyone, and welcome to the first video of my Science 9 chemistry review. So in this video, we're going to go over the organization of the periodic table, as well as how to read it, and then we're going to differentiate between atoms and ions. Okay, so the first thing is that on the left side of the periodic table, we have our metals. And on the right side of the periodic table, we have our nonmetals. The periodic table is also divided into periods, which is the horizontal row on the periodic table. So this, for example, would be a period. And the periodic table is also divided into families or groups. They're used interchangeably and are the columns on the periodic table. So I'm just going to highlight a column for you. What also is to be known about families or groups is that they share similar physical and chemical characteristics and have the same number of outermost or valence electrons. We'll go over more of that in the next video. So let's just go over some of the important families. So we have the alkali metals in red, the alkaline earth metals in orange, the halogens in kind of a purpley blue, and the noble gases in purple. Okay, so moving right along, we're just going to go over some definitions. So an atom contains a nucleus with protons and neutrons. So here I'm drawing a nucleus. Here are my protons. Here are some neutrons. I'm using zeros to show neutrons. And the shell will contain the electrons. Just circling them so you can see the negative signs. Great. An ion is an atom with an electric charge either from gaining or losing electrons. And we'll show an example of that just in the next video probably. And then a molecule is two or more atoms bonded together. So down here I've written something extremely important. For atoms, the number of protons equals the number of electrons. But for ions, the number of protons does not equal the number of electrons. Great. So now we're going to take the information from the periodic table and figure out how many neutrons, protons, and electrons we have in each atom. So I'm going to use lithium as our example. So specifically, I'm going to use the lithium atom. Great. Going back up here, we have lithium, and the atomic number is 3. And then here we have the atomic mass, and we're going to round the atomic mass. So we're going to round this to 7. As I said, atomic number 3. Mass number 7. For number of protons, it is always equal to the atomic number. So atomic number equals number of protons. Okay, so number of protons, 3. And as I had talked about before, for atoms, the number of protons and number of electrons are always equal to each other. So number of electrons in the lithium atom, 3. And for number of neutrons, for number of neutrons, we're going to do mass number minus number of protons. So that's because electrons are negligible in terms of weight, so we don't really look at it in the mass number. And for the mass number then, we're only really looking at the nucleus, which is the protons and neutrons. So for this lithium atom, mass number is 7 minus 3, because that's our atomic number or number of protons. So for number of neutrons, we have 4. Now we will do the same thing for the lithium ion. So the only difference between ions and atoms is that they do not have the same number of electrons. So again, atomic number, we still have 3. It is the same element, atomic number 3. Mass number, same again, 7. Number of protons. So atomic number always equals number of protons, even if it's an atom or an ion. 3. And let's jump to number of neutrons. It's, again, the exact same thing. Mass number minus number of protons. We still have the same mass number. We still have the same number of protons. So 7 minus 3 again. 4. Okay, now for number of electrons. You'll see here that I've put a positive in the top right corner because the lithium ion has 1 positive charge, a positive charge of +1. So I've written here positive ions means that electrons have been lost, and negative ions means that electrons have been gained. So this is a positive ion with a charge of +1. So for number of electrons, we have lost 1 electron. So that means we had 3 up here, and now the number of electrons is going to be 2. Because now when we do +3 to represent our +3 charge of protons, and we can do -2 because now we only have 2 electrons, we'll get an overall charge of +1. +1, sorry about that, +1, which is exactly what we have over here.